So we talked about StatPro. What we need to do in Stat is geometry properties. These are the heads that you should keep in mind and go one by one. If you are going one by one on these, your design is gonna be okay. So first we start here. This is analytical modeling, and majorly we use this for simple structures. Physical modeling is something which connects Bentley products. So Start is a Bentley product. Physical modeling basically connects Ecosim with the Start. I haven't used this feature yet, but this is kind of something which a lot of people are trying to dwell into and get some kind of good uh, outputs through it. I'll stick to the analytical modeling part of it. We start with the geometry. The geometry is basically definition of every um, geometrical property of your structure. So I'll start with nodes. Nodes you can define simply by typing here the coordinates. I'm going to do a very simple beam design because I don't have much time here. So this is where you start putting in the node. Say my beam is 2 meter long. So I give this, okay, and this is something called Start Editor. Try to use Start Editor. Uh, Once you have the nodes, then you can add a beam. It's quite interactive. Just hover through it, find out what exactly are the functions available. You should be able to do most of the things just by seeing. If not, there is also a help section available and you can use that. So I added a beam. My geometry is almost done. I don't need anything more here. It's just a beam design. One thing I wanted to do with Start Editor is make it plain because I'm not working in 3-dimensional. Okay, then I go to the properties. Properties, I can take the section database. Say I take a British section UC beam. I'll take the bigger one for node. I can pick the material from here. Okay, so I'm defining the beam section. You can also view the table. Opening on my other screen, I'll drag it here. You have the all the properties available. You can pick from here. Obviously you have a little bit of concept design with you. If so, you can pick from there. You can pick what kind of B by D you are looking at, and depending on that you can pick the section. I'm just picking one random section and add and close. Once I pick the section, I have to assign it. So there are a lot of options available to assign. One is assign to selected beam. So if I click here, simple click, it selects the beam. I can assign it to the selected beam. That is one way, or I can use the cursor to assign. Or to edit list, obviously this is beam number 1. I can just write 1 and enter and it will assign. Or I can assign it to view simply. I'll go with assign to selected beams. Yes. So properties is done. Materials, we saw the materials coming there. If you want to edit or add some other material in it, you can do that. One thing to know is, although Stat does allow for wood, have this wood option here somewhere if I'm not wrong, but you cannot do design of wood using Stat without defining the orthotropic 2D properties, because it doesn't consider wood as isotropic material essentially. Anyways, if you have to create a new, you can just pick anything, put it's a all I want concrete 32 say, or I want anything with steel 41355. Then you can just put whatever values you want to put in and you are ready to go. Once you define the materials, you go to specification. Specification, if you see the beam specification, there are a lot of things that you can define in this. You can release the start or end of a beam. That is the most common operation you'll use. I'm not using it right now. You can offset it. You can make one element inactive. you can release and what else, tension member. If you have something some member which you just want to behave in tension and nothing else, say you have a cable kind of a thing, or you have um, plate kind of thing which you want to behave only in tension, then you use this property. You have truss element. If you are using if you don't want to use, so one way of using a truss is giving releases, other is giving it as a truss, so it understand that it's just a axial force that it can take, and it will not take the moment from the connection. Okay, so I don't want to add anything, I'll just let it be. You can give, okay, this is a little too advanced for now, we'll drop this. So these are the specification. Then you go to the supports. Supports are again very intuitive, very easy to understand. There are only two nodes here. Instead, you can give supports only at nodes. There is no other way of giving support to, you can give it to plate actually, but I don't, yeah. So these are the options available. Majorly, you can give it only at the nodes. So you have fixed support or a pin support or fixed part. So if you have some kind of spring defined, you can just use a KFX and KMX values and define a spring, whatever spring you want to define, you can use it. Same goes with the multilinear spring. If you have some kind of pile going down, which has different stiffness at different length, you can define that here very easily. And there is one thing as a foundation load. So if you have a base plate or say a ground beam, something like that, in that situation you can use foundation loading, foundation support, where you have elastic mat and plate mat. Depending on your situation, go to help and read through it. It's quite intuitive, and you should be able to understand that very easily. I'll not go too much into it. I'll pick a pin support simply, and I'll use cursor to assign. I'll assign it both the sides. Okay. Okay, so we did geometry, we did the properties, we did material specification support. In geometry, I will like to show you everything here. So you can move nodes, merge node, renumber it. There is something called circular repeat, where you can make a circular structure out of your existing. Say you have this beam and you want to make a circle, you can make it. Another thing is translational repeat, where you can just go on repeating this at particular distances. If I open it, just one spacing, let me give you three spacing, 5 meters. I didn't pick again Z direction, but I haven't picked that. Okay, so just created node. There is something utilities you have, node to node distance. This is very important feature to know, and you can know that I gave 5 meter distance, so it copied it three times at distance of 5 meter. I'm simply going to do Control Z to get out of it. Other features that you have in here are add plate, add solid, and physical member layout. This comes again from this physical modeling. And in beam, you can insert a node in between, or you can stretch the beam, you can kind of intersect the beams and all. As the complexity of the structure goes higher, all of these utilities comes quite handy. Then we go to the loading. Loading is again very easy. There are definitions available. You can define your the most used amongst this is a vehicle definition. So you can define what kind of vehicle and all, but I'll not go into it. It might take some more time. I want to. Okay. So load case detail, here you add primary load, say dead load. You just add a dead load. You add load case 2, that will be your live load. Combination load, I'm saying just dead load plus live load. These give them the factors, say 1.35, and I give live 1.5. It's an ULS combination. I give it number 101. I give. I also define it as ULS so that I know what exactly it is, and I add it. That's it. Okay. In dead load, I want to now once you define this load here in load cases, you go to add, and that's where our window was, and we defined the load cases. In dead load, when I click add, you get a different window, and these are the types of loads that you can apply and start: the self weight, the nodal weight, the member load, and all. For the dead weight, I'm just using self weight with a 5% extra margin. In Y, this is the global Y. Be aware of the global and local accesses while working with any software. You just assign it. The assigning is same as what we had before. So I select the member, I say assign to selected beams and finish it. Okay. And then I go to live load, similarly add. This time I'll go with a member load. I'll say I have say -5 global Y. If you have local, this is local, and if you have perpendicular, this is also available. And you also have D1, D2, D3 kind of things, which you can just pick from here and apply. Okay. And you add and close, and you apply it again to the selected beams. Once you are there, you go to analysis and design. You give analysis command, define command, print, see, perform analysis. Once you see this perform analysis here, you run analysis. There is also one feature that gives you design of this steel, but I'll skip it for now. It runs, there is no problem, there are no warnings. If there are warnings, please look into it. Any warning suggesting instability, do not ignore it. Any warning suggesting some other thing, look out for it. Find it and help. If it's something you can ignore, but be very cautious about the warning part. The STAT, even if it's an unstable structure, STAT does the analysis and gives you the results, and you will not know that it's failing. Okay, so you once you finish this, you go to post processing. And here you can see the displacement of the structure, the deflection diagram, the utilization ratio. Obviously, it will not show because we haven't defined any parameters for design. And then you can see it here. We can see the reactions here. For the live load, the reaction is 5 kilonewton and 5 kilonewton. The live load is a good parameter to judge because you know what kind of loads you applied. So if I put, we applied 5 kilonewton per meter on a 2-meter long beam. Obviously, the total load is 10 kilonewton. And then it is up when you see the reaction, it is 5 kilonewton and 5 kilonewton for the 10. And that means your structure is behaving fine. So do have a sanity check on the structure. However good the software is, you need to understand this. And then you can see the combined reactions. If you want, you can just go here, combination there. This will give you the combined reaction. There are a lot of features in the software. In the need of time, I'm gonna stop here. But do look into this results setup thing. It gives you a lot of option on what exactly you want to see, what you don't want to see, what kind of tables you want to generate. This is one, you just have to right click on this. You get this results setup. You also get other tables which are quite handy and useful if you want to post process on this data generated by STAAD in Excel or something. Also do find out there are ways of connecting this directly into Excel. There are ways where you can pull in data from Excel and pull it out using very simple programming, and that is one thing which you should learn and try to implement.